Okay. We should be live here. Hello. Let me set the Twitch title real quick. I mean the category. All right. We should be good. Hey Tim. So, start of stream announcements. Where the hell have I been for a week? Comcast. Comcast. Go fuck yourself. Awful company. They basically will just dick you around while stalling because their service is broken for a week straight. Starlink gets here at the end of the week, so hopefully internet is stable until then. Yeah, it's really annoying. They have the goal to like tell you, oh yeah, it's totally on your end, and then they go, well, actually, it's kind of on our end. But now it's on your end. Oh, actually, wait, it's still on our end. Nope, now it's on your end. Now it's on our end. It's just not a fun time. Terrible company. Anyways, I have been kind of doing little bits of stuff what I can off of my hotspot in the meanwhile, plus handling a couple client things. Let me go over the current state of research. Let me go over the current state. SL took long to get there. Wait, what? Oh, Starlink. Yeah. How to get into RL research? I've been doing this since sophomore undergrad. And I was doing like random ML before that. How you can get into RL research, though, is my guides on X. I have lots of good educational materials for a variety of skill backgrounds. Okay. I'm still sort of waking up here, which is odd because I've already been for a run and everything. But for whatever reason, today's a little slow. It's actually the reason I wanted to boot up the stream. To sort of have to talk through things. So where we are at the moment, we have a version on Sokoban with a lot of domain hacks that essentially just by putting the right data into the state buffer, you can solve 15 levels in a row back to back, which is all the levels I put together for this benchmark. In 1.4 billion steps with a 50k parameter model, which takes about 4 minutes. Without the domain-specific stuff, it doesn't work. So we are essentially now, we have a version that's decent but doesn't solve. It gets like maybe 13 score. And then we have the Oracle version that has 15 score, and we're going to try to push from both directions in order to get back to where we have. Yeah, I'll explain. Let me actually explain. It's right here. This is what the Oracle is at the moment. So the guide, yeah, the guide is, I'll post it real quick. Going to be a slightly slow start to the morning. Yeah, so for anyone new around here, all of my educational materials, there's some on the website, but then most of them are just here on X. So some of these are cutting edge research articles. Like this is somewhat accessible, but this is the state of the art in the field. And then we have more just pure education stuff, like right here and right here. This is great if you're a newer programmer or if the way that we do things around here seems alien to you. This is how you do science and research. All my best advice in one place. Okay, so let me talk about the current algorithm. So we take the current, the standard PPO baseline. We set about 25% of the ends to use as curriculum ends. And the curriculum ends for the Oracle record every single state that is seen in every env. And as soon as an environment solves the next level, so as soon as you get one lucky solve, You take the last 256 steps, so going backwards through the buffer pretty much, you get 256 steps worth of state data from that solve. So you essentially get the full level solve. And curriculum learning just samples from this segment and resumes from everything along that solve. If you get a new solve that is faster, like a better solve of the same level, that will be used to replace the state buffer. If you get a new solve for the next level, that will be saved, but won't replace the state buffer until you are confidently solving the current level. And I think this is a smaller deal. So essentially, though, this is only 256 states. So by keeping a very small buffer of curriculum states, you can solve the problem if you know how to put the right data in. So now the question is, can we get something that is this good without heuristics? That sounds much more like... unlike Go Explore, this is not limited to deterministic environments. I actually did start with something even more like Go Explore, though, Tim. I used random exploration as the policy, but we were able to remove that and just use the policy itself, and it does even better than that, which is good. Oh, I put the... Yeah, so Arch, stuff gets filtered automatically. CL reward and terminal buffers after setting the state. So this is Sokoban Arch. This is Tim's environment. It's... I don't know if you've never seen this game. Why are these so fancy looking? Oh, here you go. So it's something like this, though this has way too many boxes. People write really weird levels with this. So you want to put all the... Why is this so damn complicated, man? Where's just like this the standard Sokoban? Yeah, this is like, you want to put the boxes onto the targets. And it's very difficult. I actually have no idea how the fuck to do this one. It's very easy to screw it up. Oh, 367. So this is ludicrously hard. Cool. That's not me just being an idiot. This is like a more simpler level, it looks like, right? This one has to go here. The trick to this one is that this one... Oh, I'm retarded. Hang on. These are like surprisingly tricky, even the easy ones. There. Okay, so that's like... So that's Sokoban. We have... How many levels in a row? 15. 15 levels in a row that you have to beat. Struggling to find main focus for PhD. Needs to be around explainable RL. So I don't think you're gonna get just like, oh, we're going to specifically do hyperprim. I think explainable RL is on its own a narrow enough topic for a PhD thesis. And then what you would do is you essentially go to different areas as you make progress and as things become clearer. So yeah, like understanding the various interactions of hyperparameters is a very reasonable thing to do. In fact, that's something that we need in Puffer very heavily. Um, there's some sort of visualization stuff you can do on policy behaviors, though I think that's harder. I think the explainability around the algorithms themselves is much more likely to yield fruit there. I also wouldn't sweat too much, Tim. Like, the important thing is that, in at least in my, you end up with a common thread around your work just naturally from doing that. Let me just plug this back in. Stupid camera thing, man. No, a level's not a general term, Arch. Know where to get started to make a population sim environment. Motivations to work on prediction markets. We do some finance type work and financial simulation professionally. Our general guides. Let me fix my stupid camera. Hang on. There we are. Yeah, it's just the general just the general environment guides are where you get started. Frankly. Hello, Jess. Just cut out for a bit. The camera or the mic? Is the mic cutting out or just the camera? If the camera's cutting out, that's fine. I can deal with that. Okay, so let me actually go through this. Internet is okay for now, Jess, actually. It's been down for a week. Starlink is here this weekend, and I'll be switching over to that. Mic cuts out? Ah, damn. Okay. So I guess the camera drop somehow kills that as well. That's really obnoxious. I will see if I can do anything about that, but we'll try this for now. Okay, yeah, so Tim, it's just like, I wouldn't sweat too much having the exact thing that you want to do for PhD. It's more you need something, an area or something. So I wanted to make a big fancy sim in order to do a bunch of research on that you couldn't do with other sims. That was Neural MMO, right? And we had the inspiration from MMOs, but I didn't know exactly every algorithmic thing or every question I wanted to ask. And my PhD was considered to have a tremendous amount of foresight and clarity. Like, practically nobody comes in with the level of specificity that I did. That should give you some context. So just wanting to make RL more explainable and having some ideas for areas where you can, some ideas for areas where with high confidence you can improve, that is sufficient. Deterministic attention transformer. Determinism. It depends what you mean by that. Do you mean you can just make it deterministic by seeding the softmax, right? I don't know if there's something else to it. I'm 2 years in. That sounds like most students, Tim. You basically, I think you should just pick like a high confidence project that you're very interested in, where you think that it's going to be, make a big difference. You spend some time on that, and that will guide the rest of your work. Hello, welcome, folks. Hopefully the internet will be stable today. I will say that Tim, just generally, if you like the type of work that you see here, which I assume you do, investing in low-level development skills along the way wherever you can is tremendously beneficial. But, there's also plenty of room for science side stuff on hyperparam sweeps and the algorithm and the like. Actually, that's probably the biggest spot at the moment where we need things, is that hyperparam algorithm. The previous method? No, Tim, this is an iteration upon it. So this is, I guess I should provide some context. So what I've been doing for the last couple days off stream is I've been essentially adding a bunch of domain knowledge to that thing until I get it to solve all 15 levels stably with a very small model and fast. And now I'm trying to strip away bits of that in order to tease out what are the actual things required to make state sets useful. So the algorithm right now records every state in per n trajectory at interval 1. So this interval is configurable. This is not domain assumption. Detects a solve using terminal plus reward and sequence pause. This is domain specific because we're treating rewards as solves. Only admits solve histories that start from puzzle entry. This is domain specific. We're saying that we only want to record states of the current level. Replaces the state buffer with the full retained solve segment. That is... I think we have this in the main algorithm as well. This is fine. Samples uniformly from that segment. That could be fine. Holds future better pending segment, but only promotes after the current saved level reaches 80% latch gate. So it's mostly around, okay, sampling differences and then the ordering, I suppose. I'm trying to think what we can remove. Is test set. So Tim, what I did is I sorted the puzzles by the amount of time that they take to solve with random actions, and I'm just using the first 15 of them. So these are the maps. So the first map is very easy. It takes 15,000 steps on average to solve it randomly. But by the end, the last map here takes 38 million steps for one lucky solve with a random policy. So, if you sum all these up, like 40, the 80, 100, probably like 150-ish million steps worth of exploration, 130 million steps worth of exploration on average across maps. That number... Proper science, start small and build it. Yeah. Hundreds of billions to solve. Right, but Arch, like, the key is those are not solvable by random exploration. You won't have an algorithm that doesn't include some additional form of state coverage, which is outside the scope of this update, that ever solves those, unless you're getting general solve information from the rest of the levels, or you're using intermediate rewards. I should mention I'm doing this fully sparse with no intermediate rewards. So this is very much more science side work, which is something that we don't see as often on the channel. But this is like essentially, I took the base algorithm, I added information bit by bit until I forced it to be able to solve this full thing efficiently and consistently. And now I'm stripping out bits to see, what can I actually do without. Yeah, fully sparse. This solves 15 levels fully sparse, Tim. So essentially, if you can get what I've shown by this very hacky Oracle method is if you get the right data into your state set buffer, you can solve the problem incredibly efficiently with a tiny model and with like one lucky success per end. Like, we're not fucking around here, right? The goal is not for state sets to be a little better. This should be the God algorithm. I've had several people tell me they could not get this working, but I think that this, like, I would be, let's put it this way. I would be shocked if this is not just the God algorithm. Yes, so Jess, I've shown essentially that if you get the right data into the buffer, it works, and now we're figuring out if there's a generalizable way to get the right data into the buffer. Oh, hey Aether, we have Overcooked in Puffer. I have not experimented with it anywhere near enough, but it's there. And I actually would really like to have somebody to do the experiments on that. It's super fast. It has like a few different scenarios in it already. It's way less code than the original crazy Overcooked code base. A lot of M's to study this for. Well, the expectation, Jess, is I'm kind of going to use Sokoban as the dev environment, and then we're going to test it on other ends. A bit like, this is substantially stronger than imitation, Tim. So it's a harder to learn signal than imitation, but because you're doing state sets, this is pure on policy RL. You can explore all surrounding states, and it works with stochastic environments as well, unlike imitation. This is a ludicrously powerful algorithm if we can find a reasonably good way to get data into the buffer. Low-level resources. I mean, the way that I started doing C is very, very stupid. We were kind of doing some Scython-y things with Puffer because I didn't know what I was doing. I ran a 50K and, like, I guess I somehow scrambled my brain because I couldn't think straight for 3 days, and then I just started writing C. I was just like, oh yeah, cool, we're doing everything in C now. And that turned out to be a good thing. But I kind of just went like, it's just, it's a basic language. There's not much to learn. Look, you have data, it's in static memory, you have pointers instead of having variables that hide the pointers from you, a big deal. So I really just sort of started doing it with very, very limited knowledge, just like whatever I remembered from my systems course a decade ago. And I suppose just based on my knowledge of programming already, it was a very natural transition. We implemented in JAX. Ours will be much faster and much simpler than the JAX one. Guarantee you. I've got a whole deck on don't use JAX. If you really need an env to be on GPU, you can write CUDA C. But most of the time, you don't even have to do that. You can write normal C and it's easy. What the hell is this? Chess is going to be goated. I hope so. Nah, the fair people would chill. Like, I'm not telling them that they're stupid for using JAX, Tim. Like, on the contrary, they're very smart, which is why they're able to make JAX work at all. It's just that they can't, like, I'm saying, like, look, you can get your stuff to work, but you can't get your stuff to work and still have free time. If you do it with Puffer, you can get your stuff to work and have free time. How to vectorize? I do a bit of Rust now. No, man. C is so much simpler than Rust. So much simpler than Rust. And I hate Rust as a language. If you want to talk about a ridiculously bloated and complicated, like, that, nothing about Rust appeals to me. Like, C is a very, very simple language. Having to vectorize shit. So you don't have to vectorize anything in your code. You use our multi-threading across envs. You literally just write like brain dead first year of systems programming level C, and it's faster than the damn JAX and simpler. And I have to not just be like ignoring shit here. I have to actually pay attention. Even though I'm basically treating this entire code branch as throwaway. Like, this is just to develop the method. I still have to make sure it's not doing dumb things. Like, it kept, like, some dumb thing over here. Streaming Oven attention. Plus Shaw? What? Shaw. Those words don't go together in any way I can see that makes sense. I'm not sure what you're on with there. Yeah, Puffer is very simple. But it also doesn't get in your way. Puffer doesn't make things simple by hiding complexity from you. It's just simple all the way through. Everyone else is stupid like in the Middle Ages. That's what I say, man. It's like, I really don't think I'm that smart. It's just I look around and everybody is like eating crayons and huffing paint. And the problem is that like really, really shitty bloated advice is now baked into all the language models. So when people like go to like check things from their favorite model, it also tells them stupid shit. Okay, so this is a small removal of domain knowledge from the Oracle. And we will see whether the Oracle still solves. It still has some domain knowledge. If this does not still solve or is much worse, We'll have to think. Like, just know how a pointer works is all. Literally that, yeah. What in the hell is this? See, this is why I say this is all throwaway, because what the fuck is this thing doing? If this doesn't work, if this does work, I will continue stripping things. If this does work, I mean, here, if this does work, I'll continue stripping things. If this doesn't work, I'll have to figure out what the hell this is. Draw advantage from the checkpoint grid. Existing pending mastery gate. Okay. So this is just because we're wiring the generic thing to something with heavy domain knowledge. So fine, that's plumbing. Cool. What's the plan today? So we are very, very stupidly taking this Oracle method that I have made to solve a very, very hard benchmark, and we're stripping off little bits of domain knowledge one at a time, one bit at a time, to see if we can get a general version of this algorithm. If we could get this Oracle level performance generally, we win. Like, we have the God algorithm at that point. Okay, fine. And these experiments aren't super long. They're like 6 minutes max. This flicker is very annoying, but can I just, like... I'm just going to make the text on this terminal super small so it doesn't flicker for stream. What's the benchmark? So the benchmark is a collection of 15 levels of Sokoban in increasing difficulty. You only get a reward of 1 when you solve a level. And if you fail a level, you have to go all the way back to the beginning. So you have to solve 15 levels in a row. Is encoding a bunch of domain knowledge an actually viable strategy? Would hate. Well, Aaron, so here, I have... Let me... Hang on. I haven't streamed in a few days, so I can barely speak in full, like, proper sentences. Let me actually formulate my thoughts and let me give you the full explanation behind this thing. Let me give you the full explanation. Okay, the prior here is that state sets should be a ludicrously powerful addition to the learning algorithm. They literally let you jump to the point in this in the problem where you're currently having difficulty and focus all of your learning efforts right there. So it literally just lets you teleport to any area in the problem that you're having trouble, or like where you're currently getting signal, without having to go through the whole rest of the environment to get there. So for very long-running environments, for instance, with environments with incredible sparsity, this should be a ridiculously powerful technique. Very, very strong prior here, right? That this type of method should work. Second point, this has almost never been tried, because a lot of more theoretical people did not think that it made sense to assume that you can set the state of your environment. The key insight from Puffer is, we build all our own environments anyways, we're really good at it, We do it professionally in a variety of domains. Probably anything that we do with Puffer in the future is going to involve us building some pretty crazy custom sims. And it's really easy to make a sim state settable. So, very, very high confidence that this method should work. Very low amount of prior lit out there on methods like this equals we should be able to just crush everything with state sets. Now, because there's not that much prior lit, it's a pretty big space of possible algorithms to explore, and my first attempts seemed really good, but then when we really optimized our baseline, the baseline ended up doing just as well, because Puffer 4 is just a ridiculously good baseline. So the standard goes up, right? As a result, I came up with a few benchmarks. I found one that now seems genuinely very hard to do without any sort of curriculum. I ran a sweep on it. We can't solve it without curriculum. I'm going to see if we can get a version of this to solve with curriculum on a small model by any means necessary, which I've done, and start stripping stuff away. That's the approach. How long is many steps? These experiments are running 2 billion steps, but it's using a tiny 50k parameter model. Pretty much, Badge. It lets you do that. Imagine having to play a symphony, right? But in order to practice the symphony, you literally have to play 30 minutes to go to the 5 notes that you keep messing up. Why don't academic people look into state sets? Academic people, first of all, they don't write their own environments. So like they're stuck with a big set of baselines that don't have this feature. They don't understand that it's really easy to make sims state settable when you're writing them yourself either. And they kind of just take the environment as a fixed thing. They're not including the building of the environment as part of the solution. It's just myopia, because it's just not enough engineering in academia. Actually, that's not like a Souls-like experience, right? Because you have bonfires. It would be like doing Dark Souls without bonfires. Okay, so this is dramatically, dramatically worse. Oh, what are very long? Yes, so this specific problem, the optimal trajectories are not very long at all. So right here, this is 250 steps or whatever. I think the full solve is only like 350 steps. However, the exploration to find this very short trajectory, it is like, here, the last level alone would take 38 million steps of random trials just to get one lucky solve with. So it's a very hard exploration problem. It scales up from only 15k random steps up to 38 million steps by level 15. The algorithms aren't that good yet. Our algorithms are quite good. If you look at the Puffer one, ever. So Puffer does make the existing stuff run very fast, but we also do our own research. Like, this is not just a pure engineering project. We have the best hyperparameter sweep algorithm out there. We have the best on-policy learning out there. We have the state-of-the-art hardware-efficient architecture for reinforcement learning. Um, we have state-of-the-art for environment simulation for general, like, fast simulation. We have lots and lots of advancements. Ideal case is that it can be trained without curriculum. No. So it's essentially impossible that any algorithm could train efficiently without curriculum. The only other way that this would work efficiently is if off-policy RL worked, and off-policy RL doesn't work. We found this last summer. And it, like, very clearly will not work. Yeah, so it fucked it up. Cool. I thought so. Yeah, the sweeps are pretty crazy. We do need to iterate on protein a little bit more. Starting AI RL PhD student. I guess my articles mostly. How to view science, ML and, like, research. That article, was it programming an ML article, and then the RL article in particular. Those are generally my two just best educational pieces. You don't need 10K. I typically do like 1K. It does take more than 100 or 200 a lot of the time, though. Now, our sweep stuff is fairly efficient. So the reason, Tim, that you're needing it to be so long is because it's very slowly expanding the compute frontier on your specific problem. So I wouldn't be surprised that it's mostly just keeping the same hyperparameters and running for longer, in your case. Like, we could probably just try something like that, or we could try to, like, fit. You probably could just fit a line to the Pareto frontier. I wouldn't be surprised. Okay, so this is where we have to be careful because this has probably just fucked a whole bunch of things up. This is also one of the reasons I wanted to stream today because, like, yes, it's faster to do this with Codex than it would be for me to do it myself, but it's also incredibly irritating because it just does random stupid shit. Uh, wait, Tiny Puff 1? Tiny Puff 1 is not supposed to be down. I'm gonna be very annoyed if it is. Nope, Tiny Puff 1 is there. Check tail scale. And ask Spencer if he's doing anything. Expanding compute and testing loads of stuff. Yeah, so that makes sense, Tim. Is it actually doing 10K runs, though, or is it just, like, taking forever on the existing runs because they keep getting longer? Need some training first anyways. Wait, to know which state sets are challenging, wouldn't we need some training first? Yeah, so the mental model you should have for Sokoban here is that you'll very quickly learn that value function should always be 0 because you never get any reward, right? And then the first time you get a reward, you'll get a big spike in advantage, and that spike in advantage should be enough for you to fill the state buffer without knowing anything about the domain specifics. So first, any sparse reward problem should look like that. I'm letting it do all this crap, but we're gonna check here. Wouldn't hit the limit. Wait, what do you mean the limit? 10K experiments? Hmm. I code a lot by hand. It depends what I'm doing. Like, none of this stuff is going to get kept in the final version. So basically what I'm doing now is this is just rapid prototyping of research stuff, with the assumption that all the code for this is going to be total crap. And I'm going to have to first pare this thing down to a much more minimal implementation with Codex, and then I'm going to have to go through it by hand, and I'm probably going to have to re-architect it multiple times because this thing is integrated it completely stupidly. Generic states scoring. Oracle admission is solve only. Break for solve segment. Okay, so it's still done something ridiculous, but at least we'll be able to see if this does anything. Well, I'm not letting it figure stuff out, Badge. I'm not just like saying, hey, come up with ideas and implement them. I'm guiding that process completely, right? I'm saying, okay, implement this, implement that, change the algorithm like this, change the algorithm like that. So I have this thing has basically added like none of the core ideas on this algorithm autonomously. What it is contributing is fast, well, not run fast, like very inefficient, but it's contributing quick, like dirty versions of those implementations in CUDA, which, as you can see, I've lost most of the speed of Puffer in the process of doing this. But like this is still 3 to 4 times faster than it would be in PyTorch. So this implements very shitty version in CUDA on the code base. I run experiments. If this number gets 15 without using domain knowledge, we win. And like, once I get the generic version of this algorithm to work, assuming that I can, then I will be manually or much more directedly paring down the code. And then I'm going to make sure that the final version of the code is clean and fast and correctly designed and all of that. The ideas have to be very well described, though. The idea cannot just be like, implement an algorithm that uses state set to improve performance, right? Like, I wrote a precise spec such that anybody that implemented that spec would get pretty much the exact same thing. That was my starting point, and then each change from there was a well-defined operation with very little ambiguity. Yes, I am testing the new algorithm on Boxabon. This is a version of Boxabon that I did on top of the original that gives you a fixed set of 15 levels in a fixed order. And you have to solve all 15 levels one after the other in order to win. You only get one reward per level. So it's very, very sparse. And this is a good test algorithm. You can also see the shit tons of metrics here. Like, for instance, these metrics, this is the number of millions of steps that it has taken after it gets its first reward on level 1 to achieve an 80% solve rate on level 1. And, like, on level 10, it's 48 million steps from the first reward until it fully solves. And I've been testing all of these with various different methods as well to make sure that we're consistently latching on in a reasonable amount of steps. There's quite a bit to this thing. Going through research, try to provide meaningful contribution. Thank you. I stream most of my research. I was supposed to be live the whole last week, but then Comcast decided that that wasn't going to happen. I do have a meeting today in a couple of hours, hour and a half, and that'll be a long one. Got some client work to do. Might be back after that, depending. We'll see. With multi-agent planning, hopefully using Puffer. Hope so. And yeah, congrats on that. Multi-agent planning. We have lots of multi-agent M's. We have lots of multi-agent M's. The one piece of advice that I would definitely give you on that is don't assume that you need like a model-based or explicit algorithm to do planning. I would lean much more heavily towards like probably current good algorithms can do a lot of that stuff implicitly and spend a lot of time making sure that you know the real failure cases before you go making new algorithms. I'm porting an empty state set. Should I do that myself? Or can I have an LM do it? If you have a well-built puffer env, like on 4.0, you can literally have an LLM do it. And the reason I say that, Arch, is there's only really one way to do it. Like, you need to make sure it doesn't do anything stupid, but it's basically just taking almost all of the variables from your env, putting them into a new state struct in contiguous memory, and then replacing all the call signatures on functions from, like, env pointer to state pointer. That's it. Yeah, that's exactly what you do. You reference this thing, you give it the like the exact spec of how we do our state sets. Um there are a couple places where it does stupid things, I noticed, but for the most part it's fine. Okay, so this still works. Oracle admission is solve only. Mastery gated promotion. Places the whole buffer with one solved state. Upgame mixture of individual states. Hmm. I'm just trying to figure out what we can ablate here. The problem is it's very brittle because it has one segment. Number 1 on Kaggle is using RL. Go for it, man. It'll be fun. I'm trying to think how we should, well, we'll have a few decisions to make here. I think we can probably quite reasonably get a larger buffer version of the Oracle to work. Then we can ablate one of these other things, perhaps. Yeah, so this is a difference in what I expected. It looks like we might end up having to save trajectory segments instead of saving individual states. Blah, 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 blah. It is somewhat obnoxious that it's like this. But the thing is, when you get high advantage data, right? Wow. This is more so a matter of the way that we have our rollout structured in segments. Let it do all this crap and we'll test. Okay. So if this does work, we're all good. If this doesn't work, it actually would be kind of weird if this doesn't work. We will see. Essentially, this is just giving more diverse state set data to work with. So this should be substantially more robust, I would think. Okay, we'll see if this is stable. If this is stable, the gating maybe. Yeah, the gating. Not get ahead of ourselves, but we're going to try to ablate the gating next. If this works. Okay, we're on 9. No level 10 solves. So this stays at -1, you see right here, this metric, until we get a lucky solve. So right now, that was when we got the first lucky solve of level 10. And then we're going to count the number of million steps it takes before the policy learns from getting the first solve. So right here. It took 80 million steps from the time that it got the very first solve until it was consistently solving level 10, or 80% of the time. Which I think is actually very reasonable, because we're only allocating like 25% of the ends to use curriculum. So I think this is perfectly fine. We're on level 11 in 2 minutes. And we're jumping straight to 12, it looks like. Yeah. We're at level 12. That's good. Need 15, though. You really need to have the full benchmark solved for it to be convincing. The current domain knowledge, um, it's using knowledge of the level structure. So it's basically keeping data in the buffer for the current level until you're consistently solving it. So if you get lucky solves of the next level, it's not sticking that in yet. And there are a few other things to it as well that make it like substantially domain engineered. Now, the thing is, we don't actually understand at all to what degree we need these things, right? We just have them at the moment. Uh, it got stuck a long time on level 13 there. Okay. It did get just stuck for a long time. Oh, hang on. No, we're on 14. This is not bad. It is possible to get unlucky on a level for a little while. 15. Come on, get level 15. It hasn't even gotten a single lucky solve on 15 yet. So right now it's not expected to start learning. Really? No solves? Isn't it supposed to just be like 38 million? I guess we do have to wait all the way. Yeah, okay, it's supposed to be like 100 or 200 mil. Okay, that's fine. Still no solves. What the hell? Looked fine. It just got stuck on this for too long. Entropy is high. I don't know how we wouldn't be getting a solve. I mean, it is possible. It's entirely possible to just get unlucky here. Because it's like 38 million, 4. Yeah, you can just get unlucky. Not this unlucky, though. Yeah. Oh, it got it right at the end. Yeah. It's not going to have time to learn this. Weakest blocks by highest advantage. It should be latching on. This is actually where we're going to be able to use advantage. We're testing that, Tim. Yeah, Jess, so that's what I'm approximating in my head, is like, we got unlucky, but we really shouldn't have gotten that unlucky, so there's something a little wrong. Yeah, no, I'm doing decently well here, Jess. As you can see, this type of work is just really slow and obnoxious because it's very experiment bound. And I managed to get it down to a 6-minute experiment for testing, but I couldn't get it any lower than this because 4.0 is just so ludicrously good that a lot of quite sparse problems that you can solve faster than this, like 4.0 will just figure it out. We pick the 15 levels. Yeah. So Tim, I literally I took the first 1,000 maps of Sokoban and I ran 1 billion steps of random exploration on each of them. Oops. Tim, I swept the hell out of it, so if it solves it, I have no idea. And even the ones that did decently well, I think we got to 11 at some point. It was with a really long run with a giant model. This is basically the most confident I can be reasonably about a benchmark with this. Every single person said their paper was reviewed by an LLM. Well, stop submitting to fucking conferences, man. Literally delete peer review at this point. It's doing nothing but wasting everybody's bloody time. Unless you're gonna say like LLM review equals banned from like banned from conference, and your organization is banned from conference as well until they fire or expel you. That would work. How would you run the process for review? If you wanted to do a review, it's very, very simple. Like, your qualification has to be more than ever got a paper accepted anywhere. And there would probably have to be some sort of some sort of automated review just to get rid of LLM written papers. But aside from those, like the policy would be if you use an LLM, well, the policy would be if you submit an LLM written paper or if you submit an LLM written review, you're banned from the conference, and your company or your university is also banned from the conference until they expel or fire you. How's the RuneScape end coming? Val is doing great on that. And so is John with his Fight Caves end. Okay, this is good so far. We'll see. We'll see if this helps at all or not. Huh? Why'd this gate go off on L11? That's weird. Yeah, the gates are closing wrong now somehow. Stupid thing. We'll see if this does any better. If not, we'll just go back. They took issue with my puffer white paper. Yeah, which won best paper reward, basically same manuscript at RLC the next year. So same conference. Factorio type env. You could implement one, but no, we don't have one of those. Action spaces would be a little tricky. General are hot mess. The thing is, like, there are people who are genuinely trying in that space. It's just like the administration incentives combined with the conference system and the review system, like basically everything conspires to prevent you from actually being able to focus on the shit you care about. And the funding system, don't even get me started on that crap. Is this prioritized at all? This doesn't look prioritized. Uh, no, it's on there. Hmm. How would I resolve that? Well, with my paper, the guy didn't submit a real review. He pasted it into an LLM and biased the senior review. So that would just be like insta ban from conference and also sanction the guy's organization. Like people do this shit because there are no penalties and they get away with it. ICML, I think was it ICML? One of the conferences actually did something good, which was people that submitted shitty LLM reviews had their own papers rejected. That was good. Where you get paid regardless of being well, academia is actually where you get paid nothing regardless of if you're mediocre or not. So, yeah, very socialist. You get paid nothing regardless of anything. It's actually worse if you're better, because if you're better, then you're explicitly choosing to make like 20 times less than you could make easily elsewhere. Okay, so this one does worse. I don't know, Angolf. I think that there's a very decent chance that in 20 years we treat the AI CEOs today worse than we treat like the cigarette execs. Yeah, but Ingolf, that's on them for being lazy, right? Like that's the student's fault. I mean, that's not like saying nobody should go to university. That's just saying most people that are there shouldn't be there in the first place, which was already true before AI. System enables. No, it's the system's fault that this stuff passes. It's the student's fault for taking advantage of it. Yeah, if you don't enjoy, like, if you don't enjoy the thing and like you have absolutely no interest in it and it's just a vehicle to make money, like stop. You're always going to be bad at it. Like go do something else. Like most people I knew at Stanford in CS should not have been studying CS. It's also incredibly depressing to people who actually give a shit to be surrounded by people like that. Like, that I will say is not your fault. If, like, you're super depressed being in that system, that's not your fault. That's the system's fault. But if your response is like, oh, well, these people don't care, so I'm not gonna care either, that's your fault. You're heavily incentivized. Cheating is not the system's fault. That's your fault. Being super depressed because a bunch of the people around you got their way but there by cheating, that's not your fault. I worked well over 100 hours per week through all of my formative years. I did not cheat on any of my stuff. I was super overworked and depressed because it's impossible not to be when doing that much stuff. And, it would definitely have helped if others were not just skating by doing that, but that still doesn't justify cheating. Coding functional languages on papers and exams. Don't take a functional programming class. That easy. We're trying to do actual stuff here. Let me not get sidetracked too much. I'm trying to figure out why this doesn't work with a larger buffer. We definitely don't want to prioritize by advantage. That's too much. My university and undergrad. I know, I didn't feel like undergrad was competitive at all. It was mostly just like trying to minimize the amount of time that was wasted by bullshit classes. So I could do research and do like actual stuff that mattered. I want to do a program in order to make money. CS generating change the lives. It have you ever had to work with the code base of somebody who just clearly does not give a shit and is treating it like, a whatever 9 to 5? These people make a lot of money by doing millions and millions of dollars in damage to their companies. Like, literally, one bad programmer on an important project can easily do tens of millions of dollars of damage by, like, making the entire team just unable to do anything. I've seen it happen many times. It's like you don't see it because it's writing code, but, like, you wouldn't want a lazy bridge engineer, would you? No. Like, code is load bearing on all of modern life. Like, CS in particular is a discipline where it is very, very common to find people in their first couple of years that are better than people who have been doing it for 20 years. I guess another way of looking at it is not just pure laziness. Like, there are many jobs that you can do that are hard, but you can do them while just completely mentally checked out. You cannot program this way. Like, even what I'm doing here, like, this feels fucking terrible because of the lack of responsiveness, and the long feedback cycles between what I'm doing. Like, I absolutely hate having to do this type of work. I'm gonna be way happier once I get back to, like, getting into the actual puffer internals and figuring out how to efficiently integrate whatever solution we come up with. Because this is basically me just thinking like, all right, how do I fix this thing with the algorithm? How do I fix this other thing with the algorithm? And then having to wait 10 minutes to see if I'm right. Back to 13 score, 14 score. Is this gonna work? Is this gonna work better than before? Gotten a 15 solve. Yeah, so we're just waiting. Okay, there's the 15 solve. Come on, latch. Latch, come on. Okay, it'll be on par, I think. Unless it doesn't latch. Aw, that would be so weird, though. It'll just take it a second. Yeah, there we go. It latches. Cool, 1.2 bill. Okay, so that's on par. We're good. Yeah. Okay, so this is good. Okay, so top K best solved segments is good. Dynamic environment? What do you mean dynamic environment? Paddle, paddle. Huh? Okay, so the admission, this is still domain hacked. Using solved segments is domain hack. Segment level ranking. That's fine. It's mostly mastery. Torch versus Jax. Torch is a good design implemented terribly. Jax is a terrible design implemented, like, decently. Oh, it latches like that? Why is it so spiky? Yeah, so Finn, this is kind of the theory with, this is sort of the theory with Puffer 5, is that we should be able to get efficient credit assignment from a single lucky reward. And it seems like if you have good state data, this is mostly true. It's just a matter of how do we automatically get good state data into the buffer. Market order book for market me. Yes, we do that type of stuff professionally. Our main professional service at Puffer is we build high performance simulations for a variety of domains, including finance and commerce. Part environments is a variable that changes. Dynamics of the env. A variable. Is that variable visible? It depends how you have it set up. Is the variable, like, can you observe the variable? Is there any way to see what instance of the problem you're in? So it is a little bit delayed, Finn. However, a lot of that I've found is just due to the mini batch size. So, like, it's not actually getting that many gradient updates in this many steps. There are a few cases where it seems like it's a little too delayed. However, I think it does somewhat make sense because you have to realize it's not getting an expert trajectory. It's getting a really, really crappy trajectory that solves the level. And this is not like the time to do imitation learning. This is essentially the time that it has to take through random resets to, like, get the last few stages and then get the middle of it and then get the start of it and get it all the way through. So there is still quite a lot that has to be done. So it's not guaranteed that it will latch instantly from, instantly in very few steps, but you should not have to go get the reward again, at least. You should be able to do it just from the curriculum buffer. Variable is visible. I'd need to know more about the problem then, because in theory, that seems like that could be totally fine, and we do that type of stuff all the time. Cheap chip design. I don't know. I really don't watch very many, like, technical podcasts, to be honest with you. We'll try that. 12:10. I'm gonna give myself a little bit of time before my meeting. So 1. Battery energy trading agent. Oh, we literally have an energy trading sim, though it's a very basic, like, that's one very basic part of a much larger sim. Um, it's open, that's open source as well. That's for Archive. Repos on the Puffer GitHub. Conditioning behavior on maximum usage. Unless you're setting something up weirdly, that type of problem seems like it should just work fine. If I get this algorithm, this is going to be an awesome blog post. It's literally, we'll just title it "One Reward is All You Need." Man, I was so annoyed, though, that I didn't just finish this in the first week. I thought I was literally just going to have this done in a week. Um, I think probably if I tried the original algorithm versus Puffer 3, I would have been done in a week. But Puffer 4 is such a strong baseline that you actually need to be doing some pretty smart things to do better. One cookie is all you need. One Comcast day is equal to an eighth of a real day. Fair. Yeah, you do. Like, that is a risk, Finn. But the thing is, that's supposed to only be a risk of the Oracle policy or the Oracle method. We have stuff built into this in the general method that should work for that. But because we're still ablating versus Oracle, we're just ignoring the problem for now. We'll see if this works. I think the really big one is this mastery gate thing, which is essentially not letting it get too far ahead of where it's currently solved. Did you see the final form? Yep. Yeah, this idea just, I think in some sense, this has to work. It might just be that the problem has more subtleties than you initially would tend to appreciate. This is not doing great. Yep. Okay, so whatever we're using right now for the metric to admit segments is not good. We'll try this, and if not, we'll just go start ablating different methods, metrics. Which is fine. I have not checked this in a while. Anything? Nope. Just the stream notifications. What is RAM? Yeah. That's funny. AI is very profitable if you're NVIDIA. Does the policy... Oh, yeah, I already answered that. All right, cool. So we'll see. Without the mastery gate... Okay. So essentially the concern here, right, is that it starts to get segments or advantage segments that are too far ahead. It's fine so far. But I think what could happen here, right, is like one of the segments that takes a long time to latch. It's very possible that this thing fails. If it doesn't fail, that's one very, very big chunk of domain knowledge ablated out, though. See, we're already on 10 here. Okay, that latches 10. Long range spatial. You do not want to be putting 1024 by 1024 into a neural net. That's a million obs. So, a long memory and some partially observable thingy. Some partially observable setup. This is actually incredibly clean. We're going to commit this one if this is 15 here. This is a new best. That's awesome. Come on, don't fail on 15. Oh, perfect. Holy crap. Yeah, that's 750 mil steps solved. Jeez, man. We do authentication real quick. That's a win. That's a nice win for the morning. So we're basically down to just a few little bits of domain knowledge to ablate out, and it's probably going to come down to just the like the criterion that we use to put stuff into the buffers. That's pretty awesome. No, I didn't remove the walls. It's not touching the env. It's a valid question, Jess. What if you need something like a maze search where you need that long range? We have the best maze policy out there. Like, I'm pretty sure we have the best mazes for just your standard on-pol RL by an order of magnitude. We just have a very good memory. Like, the network just has good memory in it. Plus curriculum. Memory plus curriculum is all you needed. Oh, have you seen... So our policies are way better than this now, but... Do we have this on the website? I think I did put this on the website. Literally. Alright, just go to Ocean and watch our maze solving policy for a little bit. Come on, load. There. That's our maze solving policy. It can only see a little box around itself. This thing doesn't use search. Doesn't use any heuristics. This is just like your standard on policy RL with a standard benchmark. Now you see it's not perfect. It explores like very wide ranges of stuff, but here it needs to know to make this turn to proceed. This is a very hard maze if you look at it, like to go around this way. See, like it went down, this is an entire trap here. But it's got this very good coherence to it, right? Where it's like, it's not just like jittering in one little tiny portion of the maze. And our current maze models, I believe, are even better than this. So it's explored like 2/3 of this maze at this point. You do eventually get limited by the memory. Like, it doesn't know that it's like, this is 100 steps or whatever. Here, let's say this one. Well, that's pretty good. It's very close. Oops. As soon as it makes this turn. I wonder if I have it set up deterministic with the action sampling. Wonder if I take over. I bet you if I nudge it a little bit. No, I can't. Yeah, if I nudge it a little bit. Then it figures it out. It didn't know that last turn for some reason. Maze search. These don't use search, though. This is literally just on Pol RL without even a special model. I'll search, yeah. Well, presumably this update will help with mazes a lot as well. We will see. Okay, build this. The heck? Got to close a window. Ay, ay, ay. Mm. All right, so if this works, I'd be pretty surprised if this works, but this would save us a lot of time. Hopefully it at least has the decency to fail quickly if it is going to. Interesting. I guess because it's not allowed to have... It has to wait for a lucky solve each time. Something's messed up with the metrics, though. Most ends can be solved with just a ton of interactions. No, we have algorithmic upgrades as well. Like that maze policy is better than our maze policy in Puffer 3 because of the new architecture and such. Like, Puffer is not even particularly sample inefficient. Less common jest, technically you could, but most of the time you'd need encoders. I mean, you could write custom decoders, we just haven't needed them. The only thing slightly obnoxious about that is that, we assume that the last element of your action output is for the value function. We have a fused value function head, the way we do it at the moment. Okay, this one's bad. Be done in about 10 minutes because I have to work on client stuff. Yeah, this is better. We did get one very, very good thing though, right? We got rid of there we had this mastery mechanic, which was this pretty heavy assumption that you don't get like the next level's data in your buffer until you fully solve the previous one. We got rid of that and it actually does better without it. So that's basically 1/3 of the domain assumptions we're making gone. Is that surprising, Tim? You do not understand how unbelievably cursed it has been to get this thing to fucking work. Alright? It's like, the idea is solid, but the specific implementation of state sets is going to matter a lot. Stuff does not just fall over the second you do anything remotely state set based. It seems at the moment that the Pretty much just the exact metric that you base how you put data into the state buffer on, as well as the exact metric you use for ejecting data from that buffer matters a lot. Broke something, even just fucking with logs. All right. Well, I will continue this after my client work session. Let's this convert? I'll check this real quick. Oh, very fun. You got a line follower? Heh, that's fun. Nice, man. With Puffer. Cool. Okay. Um, Thank you very much, folks, for tuning in. I might be back in the afternoon. We will see how the work session for a client goes. If you're new around here and you have not starred Puffer on GitHub, please take a moment to do that. All our stuff's at puffer.ai. And it actually helps out a huge amount. Like, you'd be surprised how much just starring the repo helps us. You can follow me on X for more content. You can join Discord if you want to get involved with dev. More research streams coming soon. Hopefully we'll have the algorithm finalized in the next few days. Last question here from Anch. Quick question. I'm waiting for question. So I wasn't paying. Summer class to get into the grad program. I don't know if that helps you get into their grad program at all, frankly. I guess maybe a strong letter of rec could help, I suppose. It really depends on circumstances. I will say that well, if you're currently a high school student, I did do one of Stanford's summer programs. It was the one that just lets you take classes. And I will say that was probably the most fun I've ever had in any summer, as well as where I learned like a huge amount of stuff. So if you have the ability to do that, it's the actual. It used to be called summer college. It's the one where you just actually take real classes from the university alongside whoever else is there, like undergrads. It's not one of the bullshitty programs where they come up with some dumb curriculum for high school students. Um, the quality of the people I met in that program, like, I would say that 80% of the people in that program were smarter than the average actual Stanford, like, first year undergrad, and they were already smart, like, better by their sophomore year of high school. So I had a ton of fun with that. And it definitely helped me as well. I didn't get a rec letter from that, I don't think. But I did learn a bunch of stuff that let me do a bunch of cool research work thereafter. All right.